Hello dear students, welcome back to my YouTube channel Chemistry Simplified. In this video, I will be discussing 20 very important objective questions on UV visible spectroscopy. These questions will be useful for T.Y.BSc and M.Sc chemistry students. Let us see these questions. The question number 1 is, select the wavelength range corresponding to UV visible region. So here we have to select the correct wavelength range for the UV visible region. So options are given. The UV visible region is from 200 to 800 nanometer. So this one is given in option number B. So it is correct one. Out of this 200 to 400, UV region is from 200 to 400 nanometer and visible region is from 400 to 800 nanometer. In separate question, they may ask you what is the range of UV region. So it is 200 to 400 nanometer. Or they may ask you what is the range of visible region. It is 400 to 800 nanometer. So in this way, we have to solve the question. Let us go to the question number 2. Question number 2 is, at alkaline pH, phenol loses one proton and exists as phenoxide anion as shown below. So this is the figure. Select the correct statement regarding their absorption. Let us read the options. Option A is, phenol shows more absorption than phenoxide anion. Phenoxide anion shows more absorption than phenol. Phenol has equal absorption as phenoxide anion. D is, phenol shows absorption but phenoxide anion doesn't. Let us solve this question. So here phenol is treated with base as alkaline pH is given. Whenever phenol is treated with base like NaOH or KOH, it forms phenoxide anion. And what is important thing here, phenoxide anion shows more effective resonance than phenol. And whenever more effective resonance is present, there is decrease in energy gap between HOMO and LUMO, and due to decrease in energy gap, there is increase in wavelength. We know the relationship, energy is inversely proportional to wavelength. So if energy is less, wavelength of absorption will be more. So phenoxide anion is going to show more absorption than phenol, and it is given in option number B. Phenoxide anion shows more absorption than phenol. Here more absorption means red shift, and red shift is also called as bathochromic shift. So in presence of alkali, phenol shows bathochromic shift, increase in wavelength. Let us go for question number 3. The base value for following compound is. So this compound is given, and options are given: 246, 250, 230 and 214 nanometer. So you can see two double bonds are given. So it is diene system, and diene system is having base value, parent value of 214 nanometer. It is given in option number D. So option D is correct one. In some books, the base value for diene is given as 215 nanometer. Accordingly, you have to solve the question. Let us move to the question number 4. Question number 4 is, energy is required for the following transitions in the increasing order. So transitions are given. So transitions are n to pi star, sigma to sigma star, n to sigma star and pi to pi star. Dear friends, remember that n to pi star requires least amount of energy, whereas sigma to sigma star requires highest amount of energy. Sigma to sigma star is given as Q and n to pi star is given as P. Sigma to sigma star requires more energy than n to sigma star. N to sigma star requires more energy than pi to pi star, and pi to pi star requires more energy than n to pi star. Pi to pi star is given as S, n to sigma star is given as R. So the increasing order will be P, S, R, Q, and if we look at the options, P, S, R, Q is given in option D. D is correct one. Now dear students, the question may be asked in different way like this. Write the electronic transitions in the increasing order of wavelength. So according to the relationship E is inversely proportional to wavelength, this one N2 pi star, as it requires less energy for electronic excitation, it will show highest wavelength. So the question may be asked in this way also. Let us go to the question number 5. Question number 5 is, what is the redshift? And various options are given. Let me clear one thing here. Redshift is also called as bathochromic shift, and it is absorption to longer wavelength, increase in absorption, increase in wavelength, decrease in energy. Opposite to bathochromic shift is hypsochromic shift, that is called as blue shift, and it is absorption to lower wavelength and increase in energy. Let us look at these options. The shifting of an absorption to higher energy is incorrect one, because bathochromic is shifting to lower energy, higher wavelength. Shifting of an absorption towards blue end, this is also not correct, because there is increase in wavelength and it is shifted to red part of the visible spectrum. Third option is the shifting of an absorption to lower energy. Yes, it is correct. Lower energy, and that is increase in wavelength. So option 3 is correct one. Let us go to the question number 6. Which of the following is the principal chromophore in azo dye? These are the options: C double bond N, C double bond C, N double bond N, C double bond O. Azo dye contain N double bond N as a principal chromophore. So the option 3 is correct one. Chromophores are the groups which are capable of absorbing UV radiation. In azo dye, N double bond N is present as chromophore. Let us go to the question number 7. Which of the following absorption maxima is not in the visible region of the electronic spectrum? As I discussed with you in question number 1, 200 to 400 is UV range and 400 to 800 is visible range. So we have to see which falls in the visible range and which falls in the UV range. So 550, so it falls in the visible range. 250 falls in the UV range. 480 falls in the visible range, and 750 also falls in the visible range. And what is the question? Which of the following absorption maxima is not in the visible range? So 250 is not in the visible range because it is in the UV range. Okay. In this way you have to solve such a type of questions. Let us go to the question number 8. Given below are the dynes with different configuration. P and Q are given as dyne, and the question is P is ciscoid and Q is transcoid. P is transcoid, Q is ciscoid. Both P and Q are ciscoid, both P and Q are transcoid. Let us solve the question of transcoid and ciscoid. If stereochemistry of dyne is like this, it is called as transcoid dyne. Transcoid is also called as S-trans dyne. And whenever stereochemistry is like this, it is called as ciscoid dyne. Ciscoid dyne is also called as S-cis dyne. What is exactly transcoid and ciscoid? Whenever stereochemistry around this single bond is trans, single bond joining two double bond is trans, it is called as S-trans or transcoid dyne. Whenever stereochemistry around this single bond is cis, that is bond attached to the two double bonds is having cis stereochemistry, it is called as S-cis, that is ciscoid. This S stands for single bond. So stereochemistry around single bond is trans, it is transcoid. When it is cis, it is called as ciscoid. So here we can see the transcoid geometry is given, and here it is ciscoid geometry. So by this we can check the correct option. P is transcoid and Q is ciscoid. It was very important question as far as university and competitive examinations are concerned. Let us go to the question number 9. It is choose the right statement. We have to choose the right statement. Statements are: homoannular dyne is called as transcoid. Ciscoid shows less intense absorption. The base value of transcoid is 240 nanometer. Exocyclic double bond causes bathochromic shift of 30 nanometer. Let us discuss first question, first option, homoannular diene is called as transcoid. So this is not correct one, because homoannular dienes are the dienes in which two double bonds are present within the same ring and they are conjugated with each other. In this way, it will be a ciscoid diene, not transcoid. Homoannular is ciscoid. So the option A is wrong. B is ciscoid shows less intense absorption. This is also incorrect, because whenever ciscoid diene is present, we add 39 nanometer in the base value and the base value becomes 253. And due to increase in wavelength, there will also be increase in intensity of the transition. So ciscoid shows more intensity than the transcoid. The option is incorrect. The base value of transcoid is 215. This is correct one. Whenever it is transcoid like this, whenever it is transcoid, transcoid shows base value, parent value 214 nanometer. And option number D is exocyclic double bond causes bathochromic shift of 30 nanometer. This is wrong, because exocyclic increases lambda max by 5 nanometer. 30 nanometer is for extra double bond in conjugation. So this is also not correct. A is not correct, B is not correct, C option is correct. That is base value for transcoid diene is 214 nanometer. Let us move to the question number 10. In the question number 10, the question is given below is a cyclic 6-member enone. The base value is, whenever 6-membered enone is present, the base value for such a enone is 215 nanometer. And if we look at this option, 215 is given in option B. So B is correct. 202 is for 5-membered ketone, 5-membered ketone having enone system, and one more value 207 is for enone which is having aldehyde functional group. So here for this 6-membered enone, 215 is the correct answer. Let us go to the question number 11. 11 is which of the following absorbs at more wavelength? So very important question. Let us see what is given. Benzene is given. Second is phenol. Third is aniline. Fourth is anilinium ion. Let me tell you that here benzene will show pi to pi star transition. Phenol will show two transitions, N2 pi star and pi to pi star. Similarly, aniline will show N2 pi star and pi to pi star. And in anilinium ion, lone pairs are absent, so it will not show N2 pi star, it will show only pi to pi star. So wavelength of benzene and anilinium ion will be nearly same. Now phenol and aniline will show more wavelength due to N2 pi star transition. And out of this phenol and aniline, we have to decide which one will have more wavelength, more absorption. This can be decided on the basis of electronegativity. Nitrogen is less electronegative than oxygen, so it will require less energy for electronic excitation. Therefore, aniline will show more wavelength. It absorbs at more wavelength. C option is correct one. Let us go to the question number 12. It is the increment for alpha, beta, gamma alkyl substituent on enone. So it is very simple one. Alpha adds 10 value, beta adds 12 nanometer, and gamma or gamma onwards add 18 nanometer. So 10, 12, 18. So the option D is correct one. Alpha 10, beta 12 and gamma 18. So this was very important question. Question number 13. The lambda max in the alpha beta unsaturated acids can be determined by. This is specially for PG students. Lambda max is determined by Fischer-Kohn rules for alpha beta unsaturated acid. For UGC student, they will ask you for diene and enone, lambda max is determined by. For diene and enone, it is Woodward-Fischer rules. But for alpha beta unsaturated acid, the rules are Fischer-Kohn rules. Let us go for question number 14. The number of double bonds present in carotene is. Carotene is a pigment, and in carotene 11 double bonds are present, and therefore carotene is having such a type of bright color. Similar to question can be asked for lycopene. Lycopene is present in tomato, and which is responsible for red color of tomato. Lycopene is having 11 conjugated double bonds, similar to carotene. Let us go to the question number 15. Calculate the lambda max for following diene. So as diene is given and acyclic diene is given, so 240 nanometer is a base value. And if we write the structure and look at the substituents, you will come to know there are 3 substituents, and for one substituent value is 5 into 3 15. So by adding 15 you will get 229 nanometer as a lambda max, and it is given in option number C. 229 nanometer is correct one, 229 nanometer. Let us go for question number 16. Select one of the statement that is correct regarding unknown. Let us read the options. N2 pi star is forbidden, pi 2 pi star is forbidden, both N2 pi star and pi 2 pi star are forbidden, N2 pi star is forbidden but pi 2 pi star is allowed. Dear friends, enone is having carbonyl group conjugated with double bond, and these systems are having 2 important transitions, N2 pi star and pi 2 pi star. This N2 pi star is forbidden transition and pi 2 pi star is allowed electronic transition according to the selection rules. So pi 2 pi star is allowed, N2 pi star is forbidden. And if we look at the options, in option D they have given N2 pi star is forbidden but pi 2 pi star is allowed. Similar type of question can also be asked for N2 sigma star and sigma 2 sigma star. Sigma 2 sigma star is allowed and N2 sigma star is forbidden. Let us go to question number 17. Molar extinction coefficient has units of. According to the Lambert-Beer's law, we can write the equation A is equal to epsilon BC, and here by rearranging the equation we will get epsilon is equal to absorbance divided by B path length and C concentration. And if you write the units of these components, we can get the unit of molar extinction coefficient, that is molar absorptivity. A is absorbance is unitless quantity, path length has unit of centimeter, concentration has unit of moles per liter. So by rearranging this we will get reciprocal centimeter per mole and liter. So liter per mole per centimeter is the unit of molar extinction coefficient, and it is given in option number A, liter per mole per centimeter. Let us look at the question number 18. Defect of conjugation on lambda max is. Dear students, conjugation means increase in double bond is directly proportional. Conjugation is directly proportional to the lambda max. Means more conjugation, more is the lambda max. If we take example of diene and triene, butadiene and hexatriene, the hexatriene will have more lambda max than butadiene. So conjugation increases the lambda max, and increase in lambda max means it will show bathochromic shift, that is red shift, and the option is B, that is bathochromic shift for effect of conjugation on lambda max. Let us move to the question number 19. The electronic transition with the highest absorption wavelength is. So it is already discussed. N2 pi star will require least amount of energy and will show highest absorption wavelength. And now we are moving towards last question. Question number 20. In acidic medium, aniline shows. Let us write the reaction. Aniline, when treated with acid, the lone pair of nitrogen gets protonated, and due to protonation of lone pair, anilinium ion is formed. As I discussed in one of the question, aniline has N2 pi star and also pi 2 pi star transition, and this anilinium ion, due to absence of lone pair, will show only one transition, pi 2 pi star. So there is no N2 pi star in aniline, and due to absence of N2 pi star in aniline, there will be decrease in wavelength. Aniline will show more wavelength, anilinium ion will show less wavelength. Less wavelength, absorption is shifted to shorter wavelength, that is called as blue shift or hypsochromic shift, and it is given in option A. So dear students, in this way I have tried to explain 20 important questions for T.Y.BSc and M.Sc chemistry examinations. Thank you for watching the video. Thank you.